Okay, welcome back. This is part 2 of lesson 11. And now we're going to talk about how to add or subtract unlike fractions. So let's write that down. To add or subtract unlike fractions. Okay, and I think I warned you a moment ago that this is going to be tougher, and it is. This is going to be a little tougher than what we just finished doing. So let's write down some notes. All right, first, convert one or more. First, convert one or more of the fractions into an equivalent fraction Equivalent just means equal fraction. Okay, so you're going to convert one or both or more of the fractions into an equivalent fraction. Actually, I'll put that in parentheses, equal fraction, just in case you guys read that later and you're like, what does that word mean again? Okay, equal fraction using the LCD. Using the LCD. Here's where if we were in person, I would say, does anyone remember what LCD stands for? And hopefully at least one of you would remember. This stands for the least common denominator. And that's probably a phrase that you might remember, but you probably haven't heard in quite some time. So using the LCD, the least common denominator, so that all fractions become like fractions. That is the goal. Okay, so what we just wrote down, the goal of adding and subtracting unlike fractions is to make them into like fractions. It's the only way we can add and subtract them by hand. They have to be like fractions. Otherwise, it's impossible. So the goal is using conversion. Sometimes you only convert one. Sometimes we convert both fractions. And you'll see examples of both types. And we're going to use this LCD. I'm going to walk you through that so that makes more sense. But let's actually write down underneath all of this. You guys know what LCD stands for. It stands for least common denominator, but let's actually write out what the LCD means. It means the lowest number that all denominators, evenly go into. Okay, so the LCD is the lowest number that all denominators evenly go into. Okay, so that's the first step. We just wrote down first, you have to convert so that all fractions turn into like fractions. That's the goal. And there's only one more step, and the second step is very easy. So then second, you're going to add or subtract. So second, you're going to add or subtract the like fractions. And the good news is you already know how to do that because we just did 11 examples on how to do that. So, all right, so really all you need to do, all you need to learn still is this first point right here. We haven't done this yet, but we've already done this. So you'll be a pro at that once we get to that part of these examples. All right, what I'm going to do is actually start a fresh page because there's kind of a lot of work to show when we do these sometimes. So let me go ahead and turn the page now. And this will be our first example. And again, I need to line up my book with this video. Let's make sure we are good. Yeah, perfect. All right, the directions will look something like this. Add or subtract. Okay, add or subtract and simplify when possible. Yet again. Okay, there we go. Add or subtract and simplify when possible. Okay, so let's do this first example. We're going to do the whole thing by hand. We're going to do all of these by hand, but I also want to take a quick moment to show you on the calculator after we do this how much faster the calculator is when we're doing problems like this, especially when there are no variables involved. The calculator is a great and very quick and easy way to do these problems. So hopefully you guys have a calculator. I think the good news is, even with all this crazy stuff going on right now with the coronavirus, I think Amazon is still delivering packages, so you could order a calculator off Amazon if you really want one. That would, I would highly encourage that. It would help you a lot for the rest of this course. Okay, so here we go. We've got 2/5 plus 4/15. Here's example number 1. Now you're going to notice the first thing that you probably noticed was that these are not like fractions. So these are very different than the 11 examples we just did. They have different denominators. So when that happens, as we just wrote down a moment ago, you have to convert one or both of them so that they are like fractions using the LCD. So what you want to do is ask yourself this. You want to say, okay, look at these denominators. What is the lowest number that both of these numbers evenly go into? Now think how I just phrased that. I'm not saying what's the lowest number you can take out of these numbers. That's not what I'm saying. I'm not saying what can you divide out of them. That's not the question. The question is, what's the lowest number that 5 goes into and 15 goes into? In other words, that you can multiply these numbers to get something. What's the lowest number? Well, if you were to think about this, you might come up with 30. Okay, that's a very common response when I ask this question. A lot of people just quickly say 30. And you wouldn't be wrong. That is a common denominator that you can make with these two numbers. I mean, think about it. 5 times 6 is 30. 15 times 2 is 30. So 30 would work. But even though it is a common denominator that you could work with this problem, it's not the least common denominator. It's not the lowest. And if you didn't use the lowest, it's not a problem. It's just more work. So if you want to try to save yourself some time, you want to come up with the lowest. So if you think a little longer or use a calculator maybe, you would arrive at the results that 15 is actually the least common denominator. Because think about it. What can you multiply 5 by to get 15? 3. What can you multiply 15 by to get 15? 1. So there you go. So your LCD, I always like to write it down. The LCD is 15 here. Okay, that's the lowest number that 5 and 15 evenly go into. All right, so here's the question. If you look at these two fractions, do we have to convert both of them, or do we only have to convert one of them? Well, good news, we only have to convert one of them because this one already has a 15. So I'm going to put a check mark above that one. That one's done. But this one right here does not have a 15 as its denominator, so we have to convert it. This one has a 15, so we're going to leave it alone. All right, so I'm going to write down this. Convert 2/5. Convert 2/5. And here's how we convert it. We go like this. Converting 2/5 means you're going to go 2/5 equals something over 15. You're converting it into something over the LCD, 15. Okay, and so we kind of just answered this a second ago, but what do you multiply 5 by to get 15? Well, times 3. And so whatever you do on the bottom, you have to do on the top. So this is also times 3. And so you get 2 times 3 on the top, which is 6. So that turns into 6/15. Now, it is very tempting to say, oh wait, 6/15, I can simplify that. I can take a 3 out. You don't want to do that. You don't want to do that until the very, very end of the problem. Because think about it. If you did that right now, if you divided a 3 out of the top and the bottom, you would be going in circles. You would just get 2/5 all over again. And then you'd have to convert it back. And then you go in circles. So you do not want to simplify until the very end. This is the number that you want to use now to replace this number. We don't care about 2/5 anymore. 2/5 is gone. And now we just want to use this number. So we're going to go, okay, let's add. So now let's add. We're going to add 6/15, our new converted number, 6/15, which by the way is the same number as 2/5. We just converted it into a base of 50, denominator of 15. And then this one here, we're just going to keep that as is, plus 4/15. Okay, so we're doing 6/15 plus 4/15. And now the problem turns into this. Now check this out. We know how to handle this. We just did, again, 11 problems like this where the denominators are the same. They are like denominators. So 15, 15, they're the same. So that means our answer is going to have the same denominator. The answer is going to be 15 in the denominator. Okay, so then the numerators are 6 plus 4 on top. And so what you get there is a 10. And so now this is the place where you can ask yourself, is there something I can divide out of the top and bottom? Because now I'm at the end of the problem. And now you can say, yes, I can. 10 and 15, I can take a 5 out. And when you do that, 10 divided by 5 is 2. 15 divided by 5 is 3. And so your very final answer, the answer that you would want to give to my math lab, is going to be 2/3. 2/3, final answer. I don't have one of these calculators with me, but I always use this piece of paper. If you're using a calculator, remember, in a problem like this, okay, you can try this with me right now. This took us a little bit of work. It wasn't terrible, but it was a little bit of thinking. But this could have been done on a calculator. And certainly when you guys move on to your next math course at Tri-C, you will be allowed to use a calculator for all of these types of problems. So it is good to get familiar with it. So if I were you guys, I would try this problem right now. The original problem was 2/5 plus 14/5. So if you put that in, 2 ABC 5, right? And then plus 4 ABC 15 equals, if you do that, you should get 2/3. Your calculator should simplify it for you, which is so cool. Some of you, I think there are about, I don't know, maybe 5 of you in my 2 classes combined have a graphing calculator like this one. And so if you have one like this, let me just show you, even though a few of us have discussed this in the past, but let me just show you a way that you can do it on here. So if you're putting 2/5 in, you can just go 2 divided by 5. On the graphing calculator, it writes it as a fraction for you. And then you just go plus 4 divided by 15. Okay, so I'm just, again, putting in these 2 fractions here. Now, watch, when you hit enter, you get a nasty decimal. And so what you can do to make a decimal go to a fraction, and by the way, we're going to be doing this in just a couple of weeks once we get to section chapter 5. So what you can do now is just hit this key right here that says math, right here, this key that says, so hit math, and option number 1 there says convert it to a fraction. So all you do is hit enter and then enter again. And look what it does. It gives you the answer 2/3. It simplifies it for you. It gives it to you as a fraction. And so if you have the graphing calculator, that's how you can use the graphing calculator to arrive at the final answer, the correct final simplified answer, without having to do any work, which is really cool. All right, so let's do some more examples. That was just our first one. Let's do some more, and let's do one now with some variables. And so these are not as easy because you can't really put them in on the calculator, at least fully. You can do part of it on the calculator, but you have to know how to handle the variable part. All right, so here we go. We'll call this example 2, and we'll do 2x over 15 plus 3x over 10. Okay, so 2x over 15 plus 3x over 10. So if you look at this problem, you'll notice these are not like fractions. The denominators are different. So when that happens, it's kind of stinks because it means more work. But here's where you want to say, all right, well, we know how to handle this at least. We need to figure out what the LCD is. In other words, what's the lowest number that 15 and 10 evenly go into? What can you multiply 15 and 10 by? Like different numbers that you can multiply them by. What can you get? What low result can you get in common with these two numbers? So you could kind of go through some options. You can say, well, 15 doesn't work because 10 doesn't go into 15. So you could go up to the next highest one for 15. 15 times 2. 15 times 2 is 30. Well, 15 times 2 is 30. Can you get 30 from 10? Yes, you can. 10 times 3. So the LCD here is 30. Now again, guys, if any of you were sitting there and you came up with 60 or 90, those numbers are not wrong. Those are not the least common denominator, but those would be denominators that work. It just means that you might have to do a little bit more work and a little more simplifying at the end, but you are allowed to use those numbers as well. But the LCD usually saves you a little bit of time. So 30 is the lowest number. Now here's the thing. 30 is the LCD. That means we need to get both of these denominators to turn into the number 30. So this time, we're not just converting one fraction like we did in this example. In this example, we only had to convert this one. In this example, we're actually going to have to convert both because neither one of these fractions had 30 as its denominator. So we're going to convert both fractions this time. So let's do this one first. 2x over 15 equals something over 30. And I might as well set up my other one too. I'm going to do 3x over 10 equals something over 30. Remember, the point is we want to get them both so that they have 30s for their denominators so that they can turn into like fractions and we can add them together. Okay, so let's go to this one. 15 times what is 30? Well, times 2, right? Times 2. So whatever you do on the bottom, you have to do on the top. So times 2. So 2x times 2 is 4x. So you get a 4x there. And then over here, so now that's our new fraction, right? It's our new fraction. We'll put a box around it. Over here, 10 times what is 30? Well, 10 times 3 is 30. So then on the top, 3x, again, times 3. Whatever you do on the bottom, you have to do on the top. 3x times 3 is 9x. Okay, so I'll put a box around that one as well. So what we've just done there is we've converted both of our fractions. And that's honestly, in my opinion, the hardest part when you're doing these problems. Once you get to this point, it's really easy, right? Because now we're going to say, now add. Now all you have to do is, again, what we did at the beginning of this lesson, lesson 11. So now we're going to add our two converted fractions. So we have 4x over 30 plus 9x over 30. 4x over 30 plus 9x over 30. So now they have the same denominator. And that's important because that means our answer will have that same denominator, 30. They are like fractions. So now we can go ahead and add the numerators. 4x plus 9x is 13x. Okay, 4x plus 9x is 13x. Okay, and so then once you get to this point, you want to ask yourself if there's anything you can do to simplify the problem. And there's nothing, right? If you look at the numbers 13 and 30, you cannot divide anything out of 13 and 30 other than 1. And so you're done with the problem. That's actually your final answer, 13x over 30. Okay, so yeah, so these take a little bit of work, but they're not too terrible. I hope you feel a little bit okay about them. All right, we're gonna do 3 more like this, and then we have one little thing we have to do at the end. So let's do 3 more examples. I'll go a little faster now that we've done a couple. All right, let's call this example 3. Okay, same directions. The directions say add, subtract, and simplify. All right, so this one now is going to be negative 1/6 plus 1/2. Negative 1/6 plus 1/2. This one looks like it should be so easy, but it does take a little bit of work. Luckily, the numbers are low, so that means finding the LCD shouldn't be that bad. So again, to find the LCD, you want to say, okay, what is the lowest number that 6 and 2 evenly go into? And the answer here is 6, right? 6 is the lowest number. Now again, I know I repeat this a lot, but if you came up with 12 or even 24 or something like that, those numbers would work. It's just, it would make a little more work for yourself. So the LCD here is 6. So then I would normally ask you guys, if I saw you face to face, I'd say, so how many fractions do we have to convert here? Do we have to convert both of them or just one of them? And hopefully you guys would tell me just one of them, and you would be right. Just this one right here. This one does not need to be converted because it already has a 6 for its denominator. So we only have to convert this one. So we're going to convert the 1/2. So that means we're going to go 1/2 equals something over 6. 1/2 equals something over 6. Okay, and this is where you say, all right, well, what do you multiply 2 by to get 6? Times 3. So whatever you do to the bottom, you have to do to the top. 1 times 3. 1 times 3 is 3. So this is our new number for 1/2. We're going to use 3/6 instead. And now we're going to add. Now you get to add. And you're going to use negative 1/6, this original number right here, negative 1/6, I'm using it right here, and you're going to go plus, because it says plus here, but instead of 1/2, you're going to use 3/6, because we converted the 1/2 into a 3/6. And now you can say, okay, cool, look at this, I've got like fractions, 6 and 6, that means 6 is going to stay the same in my answer for the denominator, and now you need to do negative 1 plus 3, and that gives you a 2, right? Negative 1 plus 3 is 2. And then yet again, you have to ask yourself, can I divide something out of the top and bottom? Yes, I can. I can take a 2 out, and I end up with 2 divided by 2, 1, 6 divided by 2, 3. 1/3 final answer. Okay, great. Okay, great. Let's do 2 more, and I'm just going to pick up the pace a little bit. 5/12 minus 1/9. 5/12 minus 1/9. All right, this one's a little bit more annoying because 12 and 9 are slightly bigger numbers, so it just means, you know, you have to maybe think a little harder or use the calculator a little bit more. But whatever the case, it's not terrible. If you think about the lowest number that 12 and 9 evenly go into, it might take some time to come up with it. 108 does work. Certainly if you multiply 12 times 9, you get 108. That works, but it's not the lowest number. The lowest number, hopefully with all this rambling that I've just engaged in here, some of you have had time to come up with it, the number is 36. Okay, 36 is your LCD. And so I would ask you, do I have to convert just one fraction or both? And the answer is, unfortunately, we have to convert both because neither fraction has a 36 for its denominator. So that means we're going to convert both. Convert both. Okay, so we're going to have to do 5/12 equals something over 36, and then we're going to have to do 1/9 equals something over 36. So we're going to convert both of these fractions to make it so that they have a 36 denominator. All right, so 12 times what is 36? 12 times 3. So that means we do that on the top. 5 times 3, 15. 9 times what is 36? 9 times 4. So times 4 on the top. 1 times 4, 4. So these are our 2 new converted fractions. And so this time the problem, if you look right here, is a subtraction symbol. We have subtraction, so now we have to subtract, not add, right? So just, make sure you always look back at the original problem so that you know if you're supposed to add or subtract. So 15 over 36 minus 4 over 36, right? And so because these are like fractions, we know the 36 is going to stay the same. 15 minus 4 is 11. And so we get 11/36. And I'll just tell you, that's all you can do. There's nothing you can divide out of the top and bottom there. 11/36 is the final answer. Okay, cool. Let's do one more like that, guys, and then I just have something very small at the end because it also shows up on your exam and in your homework for the lesson 11 homework. So there's one more little thing we'll do after this last example. Okay, how about one like this? This one, I would even maybe put a star by this one. This is the only example we're going to do like this, but this does show up on your homework. I think there's like at least 2 problems like this, actually. So this is 2 minus y over 12. 2 minus y over 12. This one looks bizarre. It looks like we're taking a whole number and we're subtracting this fraction with a variable that is what is in fact happening. But if it looks tricky to you, remember, what can we do to all whole numbers so that we can work with fractions? Well, we can always put them over 1, right? So in a problem like this, if you see a whole number at the end of this homework assignment, go ahead and put that whole number over 1 every single time. So now this turns into 2 over 1 minus y over 12. And so you still have to figure out what is that LCD, right? You got to figure out what's that LCD. Well, okay, we've got the number 1, we've got the number 12. What's the lowest number that those 2 numbers evenly go into? That is a 12. That's not too hard, right? Because 1 is pretty easy, and then so it's just going to be whatever the other number is. So 12. So this one is already done. I'll put a check mark over that one. But this one needs to be converted. We only need to convert one fraction because this fraction already has the LCD as its denominator. So we're going to go ahead and convert 2 over 1. So that turns into 2 over 1 equals something over 12. All right, and when we convert, we have to ask ourselves some multiplication questions. What do I multiply 1 by to get 12? You multiply by 12. So then whatever you do on the bottom, you have to do on the top. 2 times 12 is 24. So now our new fraction that we're going to use is that right there. Now, if you go back to the original problem, notice there is a subtraction sign. So that means we have to now subtract, right? Subtract. But instead of 2 over 1, we're going to use our converted fraction here, our equivalent fraction that we created, 24/12. And then we go minus y over 12. And this one's kind of cool because notice the denominators are the same. So that means they're like fractions, so our denominator will stay at 12. But this is very cool because do you remember when we did our first 11 examples, we had a couple like this where notice the numerators here. They are not like terms. We cannot combine them. We have a constant here of 24. We have a variable here, a y. 24 minus y. We actually cannot combine those. So when that happens, that's actually super nice. Remember, that means you just write it out like this. You just write out the numerators, 24 minus y, just like that, all over 12. And that's your final answer. Now there's one last thing I do want to say about this before I do those last two like quick little things. And that is this. I've had so many students in the past, I'm trying to, again, save you from making a common mistake. They get to this point and they say, oh, but I have a 24 and a 12. I can divide 12 out of the top and bottom. And then they go divided by 12, divided by 12. And let me just stop you right there and say, do not do that. The reason why you cannot do that in this problem is because you technically have two terms on the top. Remember, we talked about terms. Terms are separated by plus and minus signs. You have a 24 and you have this negative y. You've got two separate terms up on top. They're not being multiplied by each other. They're being subtracted. Okay, so when that happens, the only way you could take a 12 out of a 12 and a 24 is if there was something attached to the y as well that was a multiple of 12. Okay, and that's not the case here. If there was a 12y here, then yeah, you could go ahead and divide a 12 out of all three terms. Okay, there's three terms technically in this problem. So again, just be very careful of that. You cannot divide anything by just these two. You only can divide if it's by all three. I don't believe in this class you will ever see a situation like that where you're going to have to divide out of all three terms. Certainly in the next class, you're going to see that kind of stuff. You're going to do a lot of factoring in the next course. And when you factor, a lot of that stuff comes into play. But I just wanted to point that out because, again, it's a very common mistake that I've seen. Okay, so let's talk about this very last thing. It's a relatively short thing. This will be at the very, very end of your homework assignment. Also, I believe I gave you one question. I think the final question on exam number 2. I believe the very last question is what I'm about to show you. So let's not skip over this. Let's make this important as well. You're going to insert less than or greater than between the fractions. I'll say to make true. I know it's not the best grammar, but kind of a poorly phrased sentence there, but you're going to insert the less than or greater than between the fractions to make these true statements. Okay, so here's the first example. We'll do 2 examples and then we'll be completely done with this lesson. 2/7 and 3/10. Now, if you look at 2/7 and 3/10, if you just look at those numbers, it might be hard for you to tell which one is larger. I mean, it is for me when I just look at those. I'd have to, maybe use a calculator or change them both to decimals, which we're not doing yet. We're going to pretend we don't even know that yet. That's coming soon. So what you want to do here is you want to convert these so that they are like fractions and so that they have the same denominator, so that way all you have to do is compare the numerators and you'll be able to tell clearly which one is larger. So what you're going to want to do for these, it's not as much work as the ones we just did, but you still want to come up with the LCD, the lowest number that 7 and 10 evenly go into. And in this case, it is 70. Now, again, if you don't pick the lowest, it's okay. It's not going to hurt you. As long as you pick a number that 7 and 10 evenly go into, you'll be okay. But it's usually nice to pick the lower ones. The lower the better. The lowest the better, right? Least common denominator. All right, so we're going to convert both. So 2/7 equals something over 70, and 3/10 equals something over 70. And so we're going to multiply. What do we multiply 7 by to get 70? Times 10. So we got to do that on top. Times 10. 2 times 10, 20. So this fraction is 20/70. This one, what do we multiply 10 by to get 70? 7. So then you do that to the top. 3 times 7, 21. So now look at our two fractions. We have 20/70 and 21/70. So which one is larger? Well, we can tell very easily now because they have the same denominator. So all you do is look at the numerators. Which numerator is larger? 21. So it goes like that. Now, technically, you don't want to leave your answer like that because these are the fractions that we converted. So you need to put your less than symbol back in the original problem. So you want to make sure you just bring it back up here into the original problem and you say, that means 2/7 is less than 3/10. Okay, because we just figured it out there. And so I guess I'll circle it here. That's your final answer. Okay, it looks like that. All right, let's do one more and then we will be done. This is a very long lesson, perhaps the longest, perhaps the hardest of all the ones we have left. So that's good news. I was able to drop the story problem lesson. So I think this actually might be the hardest one we have left in some of your opinions, which is really good news. If you can get through this, you can get through the rest. Okay, so here we go. So -3/4 compared to -11/14. This is particularly tricky, not just because these numbers are so, 3/4 compared to 11/14, those are gonna be pretty close, but also because there's negatives involved. We're gonna have to be very careful at the end when we issue the less than or greater than symbol to the final answer. All right, so let's figure out what that LCD is, the lowest number that 4 and 14 evenly go into. I'll help you out here, it's 28. Okay, 28. So we are going to convert both. We're going to convert both because neither one of these fractions have a 28 as their denominator. So we're going to do -3/4 equals something over 28. And then we're going to do -11/14 equals something over 28. Okay? And so going back over here, we say, okay, 4 times what is 28? Times 7. So -3 times 7 is -21. So there we go. We get this. And then over here, 14 times what is 28? Times 2. And so then you do times 2 on the top. And you say -11 times 2 is -22. Now this is where it gets just a little tricky at the end. You got to be careful. They both have the same denominator, which is great. That's the whole point. But look at the numerators. We've got -21 compared to -22. Which one, now careful, these are negatives, which one is greater? A -21 is greater or higher than a -22. Remember, because it's negative, so it's like the opposite, right? Negative numbers, the bigger the number here, okay, the smaller the actual number is because of the negative sign. So this one is actually smaller, this one is bigger. So then for my final answer, I just need to make sure I put the symbol into my final answer. -3/4 is greater than -11/14. Okay, so that concludes everything that I think you guys could possibly need to know for a lesson number 11. Hopefully this is good enough to give you everything you need for your lesson 11 homework and also your practice exam number 2 and also your exam number 2. All of those things have problems from this lesson on them. Again, don't hesitate to reach out to me, guys, through emails. I always appreciate them. Again, I miss you guys a ton, and I hope you guys are doing well, and I wish you the best. All right, that concludes our first lesson. I'll see you again soon for the next one. All right, bye-bye, guys.